2. Given the 2.1, given the quadratic sequence 0, 5, 14 up to 779 and 860, 2.1.1, write down the value of the fourth term T4 of the sequence. Right, so we're going from 0 to 5, then 5 to 14. So we can see that there's a difference of 5 and then a difference of 7. Of 9, sorry. That's so that's 5, and then a difference of 9. The next one, we can expect it to be a difference of 13. So that means that this is going to be 14 plus that difference, that first difference, going from 14 to the next number. So the 14 here plus the 13. So for 2.1.1, this is 14 here plus the 13, which is equal to 27. And then for 2.1.2, it says to determine an expression for the nth term of the sequence. So the general rule for this sequence, we have 0, 5, 14, 27, and we can also do the term after 27. So from 14 to 27, and then from 27 here to 44. This is a difference of 5. This is a difference of 9. This is a difference of 13. So notice what's happening here. That's a difference of 4 between 9 and 5. And then from 13 to 9, that's a difference of 4 once again. And then that means that to get to the next value here after 13, we're going to have to add 4 to 13, and that's 17. So this here was, the 44 was 27 plus 17 to give us the 44. This is 4, 4, 4. Our 2a is going to be equal to that second difference. So therefore, our a value is equal to 2 from the 4 divided by 2. And 3a plus b here, that's equal to 5. And this is 3 times 2 plus b is equal to 5. Therefore, b is equal to -1. And then a plus b plus c, this is equal to 0. And this is a minus, in the place of a, we can sub in directly. So 2 minus 1 plus c, this is equal to 0. So therefore, our c is equal to minus 1. So our Tn here, that's going to be 2n squared minus n minus 1. So you can just verify if that's in the general rule by subbing the n values into the equation. And then for 2.1.3, we are told to calculate the number of terms in the sequence. And our last term here is 860, meaning that we're going to equate Tn to 860. And Tn squared minus n minus 1, that's equal to 860. So meaning that this is 2n squared minus n minus 861. That's equal to 0. So we can use the quadratic equation to solve for n. N is equal to minus b. And our b here is minus 1 plus minus square root of minus 1 all squared minus 4 times 2 in the place of c, that's minus 861. And this is divided by 2 multiplied by 2. And this is going to be n is equal to 21, or n is equal to minus 20.5. All right, and the number of terms here cannot be negative. And additionally, we cannot have 20.5 terms. Right, we need that to be a whole number. So that will mean that there are 21 terms in the sequence. So you also get a mark for rejecting the minus 20.5. And then question 2.2 here says, determine the sum of the whole numbers between 100 and 1000, which are divisible by 11. Right, so for question 2, what we're being asked here is to essentially consider the sum of the whole numbers between 100 and 1000, which are multiples of 11. So for 2.2 here, the numbers we consider here are 1000, 100, and 1000, which are divisible by 11. The first one is going to be 100. So since we're looking at a sum here, we can consider setting up the series. So this is 100. And these must be divisible by 11. Right. So that means that the 100 there, it does not belong. The first one is going to be 110. And the next one is 121. The next one is 132. The next one is 143. Plus, this goes on up to. So since 1000 here is not a multiple of 11, we have to consider a multiple of 11 that occurs just before 1000. And that's going to be 990. So how you can find that is that if you take the 1000 and you divide that by 11, this is roughly 90.9, which means that the factor here, the multiple is going to be 11 times 90, which is 990. Our first term here is 110, and D is 132 minus 121, which is equal to 121 minus 110. And that's 11. And we can set up our Tn so that we may be able to get the number of tens. So Tn here is equal to A plus D times n minus 1. And this is going to be 110 plus 11 D minus 1. And this is 110 plus 11 n minus 11. And the last term here is 990. So 11 n here is equal to 891. Therefore, our n here is equal to 81. So that means that the sum of these 81 terms is going to be the number of terms here divided by 2. First term plus last term. And this is equal to 44,550. All right, so if you do not want to use this one, we'll call that approach 1. If that's not the equation you want to use, you can also use S81, that's equal to 81 over 2 divided by 2 multiplied by 110 plus 81 minus 1 multiplied by that common difference of 11. And this is for the 4,550. This is approach 2. So you can only choose your approach after finding the number of terms in the sequence, in the series.